I saw a video yesterday claiming to show a demonstration that 0 divided by 0 is infinity. So quickly go through the logic there, but I don't think the conclusion is valid. So what we're doing is we're looking at 0 divided by 0. Fundamentally, the problem is we have a division by 0. And we'll actually see that that's the only problem in just a moment. But, so say we've got 0 divided by 0, and we want to analyze it. This is what math does. We want to resolve this into some specific value or set of values, right? So like the square root of 7 can be positive or negative. So it's not necessarily resolving to one value, but is resolving to a small collection of values, right? So let's say we can apply algebra to this, right? So 0 and 0 is some number, x. Okay. So what he did, there's a couple things he did. Let's see if I can remember them offhand. So one of them was, in mathematics, you can, at any point in time, just take what you're doing, add 0 to it, and it doesn't change it. Or you can take what you're doing, multiply by 1, and that doesn't change it. We're going to use both of these. So here, if we did 0 plus 0 on the top, it's still going to be 0 on the top, right? Those are identical. And we divide by 0. This should still be our number, right? But now, we can break this out into 0 and 0 plus 0 and 0. And that should still be our number. But this is our original number, and this is our original number. So we necessarily have a situation where 2 times our number is our number. And we could do this any number of times, right? We could do 0 plus 0 plus 0 plus, right? However many times, all divided by 0. So we could get any number times x being x. This is a little bit further than he went. But I think you can pretty clearly see it. If I'm able to do this, then I'm able to do the same trick to this however many times I want, and it shouldn't change the value, right? So anything times our number gives us our original number. That's interesting. Another thing he did is say, yeah, the multiplication by 1 thing, right? So if I take this guy, I'm just going to kind of jump ahead a little bit. If I take this guy, and I multiply all of the parts by 1, right? 0 by 1 plus 0 by 1 over 0 by 1. That's our x. Well, there's some tricks I can do here, right? I can factor out the 1s and the 0s and end up seeing that this is the same as 0 and 0 plus 1 on 1. Right, because so our denominator is going to have to, we're going to have to find the common denominators. We're going to have to multiply these together. And then our numerator is going to be the sum of this denominator times this numerator, 0 times 1, plus the sum of this denominator times this numerator, 0 times 1. So these two things are equivalent. Right. So whatever our number is, we can add 1 to it and still get our original number. that's interesting. So we can multiply it by anything and get itself. We can add to it and get itself. Because presumably if you can add 1 to it and it's still itself, well, you can probably add other things to it. I'm not going to get into that right now, but so we have this weird situation, right, where this doesn't appear to resolve to a value. Let's look at another situation. This is where he ended it, and he's like, okay, well, what behaves like this? It's infinity. You can add to infinity and it's still infinity. You can multiply infinity and it's still infinity. Okay, not an invalid conclusion, except there's more. There's more to this story, right? So say we consider tangent. Tangent of some angle phi, right? Now, crash course in the trigonometry here. So we're going to look at our unit circle. It's centered on the origin, and it's on the x-axis. It's 1 unit out, and the y-axis, right? So here's our y-axis. Here's our x-axis. Right? So that's y. That's x. And this phi is the measure of the angle from the x-axis as we go around counterclockwise. Right? And what we're going to be taking is a straight line, and we're pulling it around. It's a unit length, so it's 1. The length of it is 1. So we're going to end up getting these kind of like a clock hand moving around, right? And that angle is phi. It's probably too small for the camera to see. And our angles, I'm just going to do it in radians for convenience, but this will be 0. 0 radians there. It would be 0 degrees as well. Over here is going to be pi radians, or 180 degrees. Up here is pi on 2. Down here, because we've come 3 of these little half pi's, right? That's pi on 2. There's 1 of them, 2 of them, 3 of them. So 3 pi on 2. And then that last one would be 4 pi on 2, or 2 pi. Right? Okay, so tangent, we're going to be looking at, and I'll blow this up a little bit. So I've got this triangle. This length is 1. This big side right here is 1. This angle is phi. This height right here is the sine of phi. This is the cosine of phi. Or, relative to the angle, this is the opposite side. And relative to the angle, this is the adjacent side. And this angle over here is 90 degrees. Alright, so this is 1. This side is known. The way that we're looking at it, this is given to us. So the 2 unknowns are these 2. Relative to our angle, this is adjacent, and that's opposite, because it's on the opposite end of the triangle. So it's right next to the angle on the triangle. And the math name, sine of the angle, cosine of the angle. Tangent is opposite over adjacent, or sine over cosine. Now this becomes relevant to our division by 0 problem very soon here. Because if we notice, as we approach pi on 2, the cosine, the adjacent side, disappears, right? At 0 radians, our line is just flat, right? So the opposite side, the sine, is 0, right? So adjacent, or opposite over adjacent, would be 0 divided by 1, So tangent of 0 is 0, right? 0 divided by 1, 0. Tangent of pi is going to be the same thing, right? Because we've got our length is 1, our adjacent side will be -1, or no, wait, or yeah. Adjacent side is -1, our opposite side is 0. 0 divided by -1 is also going to be 0. So tangent of 0, tangent of pi, both 0. Tangent of pi on 2, our opposite is going to be 1. It's going to be completely in line with the known side. It's really all we have. There is no adjacent side. So we're going to get 1 divided by 0. This is where it gets tricky. So if we drop in that full x-axis, another way to look at the tangent is, and this is where its name comes from, it is the line that's 90 degrees from the line that we're drawing, and it starts right there, and then it extends to the x-axis. So, and it's going to be the length of that line. So what happens at tangent of 0, there's no length to that line, right? Because we're already on the x-axis. And as we come around, it grows and grows and grows and grows and grows. And as we get to pi on 2, our line, our tangent line, is now parallel with the x-axis. They never meet. This is where we have a division by 0. So you can see that there's a problem here. But it gets even worse, because over here you get positive values. Over here you get negative values. And as it comes up, it goes to positive infinity, and then suddenly it's at negative infinity, coming back down towards 0. So tangent of pi on 2 is going to be a division by 0 problem, 1 divided by 0, but we cannot resolve it. Yes, in one context it acts like infinity, like the conclusion that was being drawn here, but it also acts like negative infinity at the same exact time. And it's impossible to be more different than that. If we were to plot this out, and so here we've got pi on 2, negative pi on 2, 3 pi on 2. Exactly between these, we're going to cross the x-axis. Right, so there's x, there's y. And this is in radians. As we approach pi on 2, we're going to go up to infinity. As we come away from pi on 2 on the other side, we're coming up from infinity, from negative infinity. And this just recurs over and over and over again. Right. So this is the point where we're getting division by 0. It simultaneously wants to act like infinity and negative infinity. So it can't be resolved. This does not have a value. And it's not because we're looking at limits, it's just, I mean, we kind of are, but physically, when you look at it, it's not infinity, because what we're doing is we're looking at the length of this thing before it intersects with the x-axis. It doesn't intersect with the x-axis. There's no value for that problem, that it doesn't exist. It literally doesn't exist. If we're looking at the limits, it's acting like positive infinity as we approach it from one side, and it's acting like negative infinity as we approach it from the other side. But when we look at it directly, it literally doesn't exist by definition. It does not have a value. It's not a number. It's not infinity. It's nothing. It's not math. The answer to this question is the question is broken, right? So, yeah, so we're getting some interesting things. We can also look at a very simple thing. We can literally make 0 on 0 act like any number we want, right? So say, so over here we just said let's treat 0 on 0 as something and figure out what happens. Okay. Over here, let's approach it a little bit differently. Let's look at this as anything divided by itself is 1. So, 7 on 7 is 1. 47 on 47 is 1. Pi on pi is 1. Right? But this doesn't even require numbers. This is how unit conversions work. Right? So, say I've got kilometers divided by kilometers. What is that? It's 1. It's a unitless 1. Right? So say I want to figure out how many meters are in 17 kilometers, right? Well, I've got 1,000 meters per kilometer, and we're going to multiply that by 17 kilometers. And the reason that you know that we're going to multiply these two things is because what's going to happen is I'm going to get meters in the top, and kilometers are going to cancel. Kilometers cancel because anything divided by itself is 1, and when we multiply by 1, we can ignore it. So I can rewrite this as 17 times 1,000, or in normal English, just 17,000. Right? Do math just the way we say the numbers. Meters times kilometer on kilometer. This is just 1, so we can ignore it. That's what canceling is. Turning it into a 1 while multiplying so that we don't have to consider it. Technically, it's still there, but we don't care. It's not doing any work. So this division of something by itself giving us 1 doesn't even require that we work with numbers. This works with literally anything. LeBron James divided by LeBron James is 1. And English actually uses this, right? So, seeming tangent here, but if you walk into a room and you ask, is LeBron James in this room? What you're doing is you're saying, okay, what do I see? And I'm comparing it to LeBron James. If LeBron James is indeed in that room, you'll get, if you were evaluating this mathematically, you'll get a 1. But if you're evaluating this question in English, you'll just get yes. If LeBron James is not in that room, you're going to get 0 LeBron Jameses divided by LeBron James, which mathematically is 0. In English, it's no. So, basic questions in English, yes-no questions in English, can be analyzed as a division of something by itself. Yes is when the result is 1. No is when the result is 0. And doesn't have anything to do with numbers. Okay, so if this works for literally everything, then 0 on 0 should damn well be 1. Because over here, we kind of concluded that we can't get 0 to be a number. Well, that doesn't matter. We don't need it to be a number. Anything divided by itself is 1. Okay? But, as we saw, it can't only be 1. So, this might not be a problem. Right? This is, people who see this as a problem are like, it has a 0 on top, so it should evaluate a 0. That might not be a problem. It might just evaluate to everything. Let's show an example where it actually necessarily does. So let's consider a function like y equals x. Right? Very simple. There's our y-axis, there's our x-axis. Okay, so y is always x, so we're just going to get a 45-degree line coming up, coming down. Everybody meets at the origin, because when 0 is 0, it's 0. Boom. When x is 4, y is 4. Boom. Okay. Now, because we can always multiply by 1 and it doesn't change anything, we can ignore that. We could take this, y equals x, turn it into y equals x times 1. Okay. 0 on 0 should be 1, so this should be equivalent to y equals x times 0 on 0. Shouldn't have any problems. Okay. Now, this breaks off into two ways of analyzing this. I could multiply x by the numerator, and we get y equals x times 0 over 0. And then anything times 0 is just 0. So this is literally 0 times 0. And very quickly, we know y can be any value. So I've kind of just shown that this works. Okay, that 0 on 0 is literally every number at once. Or, just kind of leave it as it is, more or less, and say that we are taking whatever our thing is and multiplying it by something, and we're getting our y. Well, we already know that that's going to work from over here. It's still going to give us 0 on 0. So we still get y equals 0 on 0. So, and y it ends up being literally every value. So 0 on 0 has to be literally every value. But we can look at this yet a different way with the same exact equation. So say I want to analyze a specific point. Let's call it M. At that point, y should also be M, because of the way this function is defined. Okay. In order to get a division by 0, specifically at this point, I'm going to want to look at, well, we've got our y equals x, and we want to multiply by 1, because we don't want to change it. The number that we're going to divide by itself is going to be x minus m, right? Because at x minus m, or at when x equals m, the value x minus m will be 0, right? So x minus m over x minus m. So everywhere except this point, this will just resolve to y equals x. At this point, it will resolve to y equals 0 divided by 0. And we can take limits and figure out what that should be. I mean, pretty clearly, I think taking the limit of this is going to give us m, but we'll see. Okay, so at m I get a 0 on 0. Everywhere else I definitely just get 1, and we're good, right? Okay. So when I take the limit from the left coming up towards it, it looks like I'm approaching m. Very definitely looks like I'm approaching m. And when I come down from the right, it very much looks like I'm approaching m. So at m, this should be m. Right? Seems reasonable. But we can complicate this. What if we drop in another one? And now, so we take this guy, just give us a lot of room here. Y equals x times x minus m over x minus m. So that's just this. But now we're going to multiply it by this other thing that will evaluate to 1. X minus n over x minus n. And I could do it for k. And I could do it for, whoops, j. And I could do it for L. I could do it for literally every point, right? Right, and that can go on forever, and I can literally put a hole in the function at every single point. And here, I'm getting 0 dividing by 0 equaling m. Here, I'm getting 0 divided by 0 equaling n. Here, I'm getting 0 divided by 0 equaling k. Here, I'm getting 0 divided by 0 equaling j. And these can be absolutely anything, and I can have every number ever, all of them. I can have all of the numbers. So 0 divided by 0 simultaneously is everything. It's not infinity, it's everything. And now if we go back to this, we can see why this works. Because what ends up happening is we sort of seem to break a rule of mathematics. In math, generally, when you set a variable to a value, it has one value. It holds that value everywhere. 0 divided by 0, or anything divided by 0, because of this, anything divided by 0 doesn't operate that way. Anything divided by 0 is simultaneously everything. So we cannot say that this x is the same as this x, even though they're in the same equation, right? So 7x can equal x when x is 0 divided by 0, because x can be 1 and 7 at the same exact time. In fact, it is. It can be 10 and 70 at the same exact time. And in fact it is. So this is working not because 0 on 0 is infinity. It's working because we cannot analyze what 0 on 0 is, because it is always everything at once. This doesn't have a discrete value. This doesn't have a discrete value, and there's nothing linking these two instances together. There's nothing connecting them. There's no reason they need to have the same value. And similarly, over here, whatever our number is, whatever our division by 0 results in, we can add anything we want to it and still get, right? 0 on 0 plus any number is still 0 on 0, because 0 on 0 can be anything and is everything all at once, and 0 divided by 0 is anything and everything all at once. So 3 plus 74 is 77. That's fine. Totally fine. And as such, division by 0, it's worse than really anybody has probably ever told you. It's not infinity. It's not undefined. It's not really math as we know it. It just doesn't work, because it's everything at once. And it's everything at once so effectively that this is true. If x is 0 on 0, then this is true. But it's true for whatever value of x I want to put in here. Because whatever value I put in for x here has no bearing on it over here. And that violates a principle that appears to work everywhere else in math. So it's fair to say that 0 divided by 0 is outside the scope of mathematics.